Hello there, Mr. Sutton bringing you the IM3-1-3 extra practice solutions on the elimination method. For this problem, I'm trying to figure out the solution to this system using the elimination method. Since I ultimately need to add some equations together, I'm going to start by checking to make sure my equations are both in the same form. So I want them in standard ax plus by equals c form. The second equation here is in the form. We've got x, y, and a number. But the first equation, not so much. I have to add 37 to both sides and subtract 7y from both sides. So for my first step, I'll add 37 over to the other side. And I could have done this all in one step, but I'll do it in two steps. So my next step, I'll subtract 7y over to the left side. And I'll just rewrite that equation down here. All right. So next step, if I add these together, will anything cancel out? And it looks like it will. These 7y's are going to cancel. So let me go ahead now and just add those equations together. 7y's cancel out. We've got negative 9x on the left. On the right, this is going to add up to, let's see here, 52? Is that right? No, 54. 54. There we go. Dividing both sides by negative 9, that's going to be x equals negative 6. And then plugging negative 6 back in over here for x. We've got 2 times negative 6, which is going to be negative 12. And then if I subtract 37 from both sides, that's going to be negative 49 on the left side. Dividing both sides by 7, we get y equals negative 7. So then my final answer, I've got the point negative 6 comma negative 7. For this problem, I'm trying to solve this system using elimination. So first, let me check to make sure these are both in standard form. And it looks like they are both in ax plus by equals c form. Next, if I add these equations together, because that's ultimately what elimination means, is anything going to cancel out? And it looks like the x's won't. You'll get 7x. For the y's, you would end up with 12y. So neither of those is a good situation. Next, is there something I could multiply an equation by that I would get opposite-like terms? And there is. If you want to get rid of the x's, you're going to have to multiply each equation by a different number. So that's going to be 2 steps. To get rid of the y's would be a little bit easier. If I just multiply this second equation by negative 5, that would give me negative 10y, which would cancel out nicely with this positive 10y. So I think that's what I'm going to do. So negative 5 times this second equation, that gives me negative 20x minus 10y, which was really the reason we did the negative 5, equals, and now 12 times negative 5 is negative 60. Now if I add these equations together, those 10y's cancel. We've got negative 17x on the left side, and on the right side that's going to be negative 68. Dividing both sides by negative 17, that does end up being just 4, which is kind of nice. And if I want to get y, I have to plug 4 back in for x in one of the equations up here. I'm just going to plug 4 in over here for this x value. So we have 4 times 4 plus 2y equals 12. So 16 plus 2y equals 12. Subtract 16 from both sides, that's negative 4 over on the right. Divide by 2, we get y equals negative 2. And then my final answer, I've got 4 comma negative 2. On this problem, I'm trying to solve this system of equations with elimination. So ultimately, I have to add some equations together and try to cancel out something like that. Now, first thing I'll check is to see if both equations are in standard form, because I can't really add them together if they're not in the same form. This first one is in ax plus by equals c form, which is what we like to see. The second equation is not, though. The x is over on the right side of the equation. So I'm going to subtract x to get it over on the left side. And now I've got the same form as that first equation over there. All right, now if I add these equations together, this first equation and this rearranged second one, will anything cancel out? Doesn't look like it will. So I'm going to have to multiply one of these by a number that gives me opposite-like terms. So you have to decide, will it be easier to cancel out the x's or the y's? And it looks like the x's are going to be a much easier thing. If I multiply this second equation by just negative 2, that would allow me to get a positive 2x, which would cancel out with the negative 2x up here. So we've got a positive 2x, but now I have to multiply the rest of this equation by negative 2 as well. So that's negative 8y. And then on the right side, we have negative 1 times negative 2 is positive 2. Now I can go ahead and add these equations together. So the x's cancel. That's good. 7y plus negative 8y is negative 1y. And on the right side, negative 4 plus 2 is negative 2. So just divide both sides by negative 1. We get y equals positive 2. Still have to find the value of x, though. So let me go ahead and plug in 2 for y. And it doesn't really matter where you do this, but I'm going to do it right here just because it's the easiest one to get to there. So we have negative x plus 4 times 2 equals negative 1. So this is negative x plus 8. And now if I subtract 8 from both sides, we get negative x equals negative 9. Divide by negative 1, we have x equals positive 9. So then my final point, we've got 9, comma 2 for my answer. For this problem, trying to solve this system of equations using elimination, since I'm adding the equations together at some point, need to make sure they're both in standard form. It looks like this first equation is in ax plus by equals c form. Same thing for the second equation, so I can move on to the next step then, which is to see if I add these together the way they are, will anything cancel out? The x's are going to add up to a 10x, which is no good. For the y's, those are also not going to cancel. So I have to multiply one or both equations by some number that gives me opposite-like terms. So my next question is, am I going to try to cancel out the x's or the y's? And either one of these is going to be about the same level of difficulty. For the y's, if you multiply this first equation by 3, that'll give you 6y. Multiply the other equation by 2, that would be negative 6y. That would allow you to cancel out the y's. So that would be pretty quick to do. I chose to get rid of the x's. So number that 6 and 4 both go into would be 12. I'm going to multiply this second equation here by 3. That would give me 12x minus 9y equals negative 69. And now if I want to cancel that out with something from the first equation here, I have to multiply this first equation by negative 2 so that I get a negative 12x, and then a minus 4y equals 4. So doing it this way allows me to cancel out the x's if I add these together. But again, you could have just as easily multiplied by other things to cancel out the y's. So really half a dozen of one, 6 of the other. All right, so now we did use this process. Let's add those y's together. That's negative 13y on the left side. On the right side, that's negative 65. Divide by negative 13, we get y equals 5. And now if I plug 5 back in over here, we've got 6x plus 2 times 5 equals negative 2. So that's going to be 10 over there. Subtract 10 from both sides, that's negative 12. Divide by 6, we get x equals negative 2. So then, final answer, we have negative 2, comma 5.